Happy holidays. I'm just making a quick video here just to explain the solutions. We'll go through quite quickly. Okay, question one. You had to use definition of ZZ bar being the modulus squared and Z plus Z bar being twice the real part. Substitute in, rearrange, you get an answer D. Question two. The best way of doing this is to rewrite I as e to the I pi on 2, and then use index laws, and then use de Moivre's theorem, and you got an answer of A. That was not okay. Question three. The easiest way was to take the argument of both sides, because we know that arg z is pi on 3, then sub that in, and use the fact that we've got an argument of a complex number squared, it's twice the argument of the complex number. So we get this expression here, and then we can do inverse tan of A. That would be what the argument of 1 plus IA is. If you look at A, you're told that A is positive and real. So therefore we get that A is 1 on root 3. The answer was B. That was done okay. Question 4 was done okay. First step was to change to mod arg form and then raise it to the power of n. We want it purely imaginary, so we want the real part to equal to 0. The real part will be this expression here. And solving that, you get a whole bunch of answers, and then matching that with what you have in the multiple choice options, the answer is B. Question 5 is done okay. The easiest way was to let z be just xy. And then you can work out what negative z bar was, which was negative x comma y. Notice it's the same height. And then it said z to the power of negative 1, which is 1 on z, which is conjugate of z time over the length of z squared, and you're told that the length of z is not 1. So applying that here, you get a particular point here. And then if you do the negative conjugate of that, you get this particular point here. And notice you've got the same y value there. So you've got two sides that are parallel to each other. So therefore, the four-side shape is a trapezium. The answer was D. Okay, question 6a. That's a typical square root question. Expand, equate real parts, equate imaginary parts, and then you can solve that quite easily by inspection. A lot of people made a mistake by putting a plus here. A lot of people got the root 3 and the 2 switched up as well. So just be very careful when you do this sort of question. Okay, question B, part I was done okay. However, I want to make a comment that a lot of people showed limited working out, and you should show a lot of working out. So firstly, by definition, changing exponential form to mod arg form, and then using the fact that cos is even and sine is odd, and then expanding the brackets. This working out should have been shown. I was a little bit lenient marking this question, but you did need to show all relevant working out. Part 2. This part was done really poorly. This was a bit of a different kind of question. I wanted to show you that it's possible in complex numbers for sine and even cos to be outside of the bounds of negative 1 to 1. So I picked sine theta equals to 2. And then you're meant to use the previous bit. So if multiply through by 2i, then you can use the previous part. You get this expression here. Now, that was the first mark. A lot of people didn't realize what to do from there and had a bit of trouble. So the trick was to multiply everything by e to the I theta on both sides of the equation. You get a quadratic equation reducible to quadratic in e to the I theta. Okay, so and then you solve it like a normal quadratic, and the final answer was 2 plus minus root 3i. Some people did it a different way, which I hadn't thought about when I wrote the question. I just realized that there's a root missing on that 3. I have to fix that up. And then using the fact that cos theta is plus minus square root 1 minus sine squared, we can get this particular answer, combining that e to the theta is cos theta plus I sine theta. You can combine and you get this answer here. Some students lost a mark. They didn't put plus minus. Okay, that question was overall done quite poorly. Next one, C. This was done really well. Okay, sum of roots to work out alpha. And then you can either expand, or what I did is I did sum of roots 2 at a time and product of roots, and it doesn't take very much effort to get that. A is 11 and the B is 17. D, this was a smarter math question. Worked out the modulus of the original complex number was 4. The argument, now a lot of people had issues with this argument and didn't get negative 5 pi on 6. That was a common error. But the principal argument there is negative 5 pi on 6, because that's pi on 6 there, and you're in the third quadrant, so it's negative 5 pi on 6. And then usual way to find fourth roots. And this was the final answer here, with arguments of 5 pi on 24, 7 pi on 24, 19 pi on 24, and negative 17 pi on 24. 1 mark for all arguments correct, 1 mark for correct modulus. Next, question 7a. So this was a cube roots of unity question. First step was to be using this property of 1 plus omega squared is 0. Or also using the fact that omega cubed is 1. So what I did for this term here to deal with this annoying fraction, I changed the 1 on the numerator to omega cubed, and then I got omega cubed over omega squared. It just becomes omega. So that makes things a lot easier to do. Some people made a common denominator. That was fine. This question overall was done all right, but there was some silly mistakes along the way. For example, a lot of people got to this stage, cubed the W, but forgot to cube the 2. A lot of people made the mistakes. A lot of people got the answer 127. So 1 mark for sufficient progress, and then you keep applying the rules, you get 133. That was the second mark. Okay, B, this was done particularly poorly. You had to either use the triangle inequality or recognize that in order for it to be a minimum, that U, Z, and V have to be collinear. So they were the two approaches. So some people did the collinear way, other people used the triangle inequality way. What's nice if you use the triangle inequality is that the Z's cancel out because you don't know Z. So that's kind of nice. And then you just work out what negative U plus V is, and then you work out the modulus of that is 10. So therefore you get this expression by the triangle equality. So therefore it would be the minimum when U, V, and Z are all collinear, and that will be when a value of 10. The minimum value is 10. So 1 mark for setting up triangle inequality or justifying that it has to be collinear. Second mark for the answer 10. Next, C. This was done okay, but could have been done better. You have to take care that you answer the question. They were looking for... Question made it really clear. We want to see open circles and closed circles, and we want to see the points where there are open circles and closed circles. Okay, so you had this expression here, which says that the distance from 2 has to be greater than or equal to the distance from 2i. Okay, so that's a perpendicular bisector between 2 and 2i, which, if you think about it, that's a gradient of -1. Perpendicular bisector will have a gradient of 1. And due to symmetry, it's going to go through the origin, so that's going to be y equal to x. So 1 mark for sketching y equal x boundary. Then this one here, angle between pi on 2 and 3 pi on 4. So 1 mark for sketching that boundary properly. And then you had to consider the equal to. Now, a lot of people stuffed up not drawing things solid when they should have been solid, and not drawing things open or dotted when they should have been dotted. So this bit here is solid because they're equal to. This bit from 1, 1 to 2, 2 is solid because it's equal to here. Closed for 1, 1. Open because the intersection of solid with dotted is open. And open here, arg of pi on 2. What else? A lot of people shaded the wrong bit. Okay, so if the distance from 2 is greater than the distance from 2i, you have to be closer to the 2i. So that's why it's shading this particular part here. Okay, next, D. Okay, this question was done very poorly. Not many people got this out at all. I changed my marking criteria to give a nice, easy first mark, so at least most of you got the first mark. First mark for just realizing that when you divide complex numbers, when you're taking the argument, it's the same as subtracting. And then realizing that arg of 3, because 3 is real, that argument is just going to be 0. So getting to the stage where this equals to negative arg 1 minus z was first mark. two ways of approaching the question from here. I'll show you. There's probably more. This is probably my favorite way. So you're told in the question that mod of z is 1. So distance from of z is from origin is 1. That also means the mod of negative z will obviously also be 1, because negative z is just a reflection of z 180 about the origin. So what you got here when you work out 1 minus z, that's 1 plus negative z. So if you add a distance of 1, this shape here is a rhombus. So O1, this 1 minus z, negative z is rhombus. Okay, and the property of rhombus, the diagonal bisects there. So if you work out this argument here all the way to negative z, that's going to be negative pi plus theta. And then if you halve that, negative pi plus theta on 2, that's going to be that angle there. So therefore, the final answer, you need to take negative of this answer. So the final answer is pi minus theta on 2. An alternate way is, because they're both the same modulus, you can add or subtract when they're the same modulus by taking out a factor of e to the I and then half the moduli here. So I did that there. I also factored out the negative to make things a little bit easier. It becomes a 2i sine theta on 2. The 2i sine theta on 2 can hang there. You deal with a negative I by writing it as e to the negative I pi on 2, and then you add the arguments, and then we get here this answer for arg of 1 minus z being negative pi plus theta on 2, and then you want to take the negative of that, and you get the same answer as before. Okay, 7e. I might do this in another video.